Hello all, myself Kalpana, Assistant Professor in Mlritm. Today I am going to discuss about the subject Electromagnetic Field Theory. This subject is for electrical engineering students in second year first semester. So today I am going to discuss about what is the electromagnetic field theory. So today I am discuss about the introduction to electromagnetic field theory. So before going to this, so the prerequisite for this subject is we need to know basic vector analysis and also engineering mathematics. So these are the prerequisites for this particular subject. So these are the contents. So introduction to Cartesian, cylindrical and spherical coordinate system, and conversion of one type of coordinate system to the another coordinate system, and next coming to the electrostatic fields. So this includes Coulomb's law, electric field intensity. Next, work done in moving point charges in electrostatic field, and electric potential and properties of potential function, potential gradient. Next, coming to the Gauss law and its applications of Gauss law and Maxwell's first law. So, and Laplace and Poisson's equation. These are the contents in module 1 in electromagnetic fields. So, next coming to the introduction part. So, what is the electromagnetic field? So, before that, so what is field? So, field is nothing but it is a function that specifies a particular quantity everywhere in a region. So let us take for example cricket or any football. So here in a cricket we have a field. So in that field includes, the cricket field does not include everything on the earth. Only it has some boundary. So where the players can play the cricket. So means field is a function that specifies a particular quantity everywhere in a region. Only it has boundaries. So in that region only, in that particular region only, we call it as a field. So this is the example for field. Next, coming to the electromagnetic field. So here, when the field is created by the electric field, then it is called a electric field. So coming to the electromagnetic field, so here, so interaction of electric field and magnetic field is nothing but a electromagnetic field. Means interaction of electric field and magnetic field in interaction of time varying electric field and magnetic field, which creates a electromagnetic field. So that is nothing but a electromagnetic field. Next, coming to the electromagnetic field theory, the theory which deals with a electric and magnetic field which is time varying in nature, that is nothing but a electromagnetic field theory. So this is about the electromagnetic field theory. So it is also in a particular region we are considering. So that is nothing but a electromagnetic field theory. So let us see how electromagnetic field theory comes. So before that, as we know that in case of circuit theory, when we apply a voltage, the current will flow in that particular circuit. Means this time varying voltage will produce as a current. Means when we take, for example, it is a conductor. So it is having some. So here I am giving a voltage here. When we apply voltage, the current will flow. So time varying current is flowing. Means this current will flow according to the time. Means charges produces a current. Okay. So means time varying current is flowing here. So means this time varying current produces a magnetic field. Why? Because it is a coil. So magnetic field is created here. So what we are applied here? We are applying a voltage. Means time varying current produces a magnetic field when we apply a voltage to the particular circuit. Means voltage produces a electric field. So again, time varying electric field. So here we applied a voltage with respect to time. So this time varying electric field produces a magnetic field. Means it is a coil. So that is the reason it is a magnetized. When we apply a voltage, current will flow. This circuit will this coil is magnetizing. So this current produces a magnetic field. Means again this time varying field again produces a electric field. Let us take for example in case of electrical machines. So this electrical machine works on the principle of electromagnetic field only. So all these are originating from this electromagnetic field theory. So that is nothing but when electric field interacts with the magnetic field, then electromagnetic field is created. To discuss this, we are dealing with static electric field and static magnetic field, electromagnetic field, next plane wave propagation. So static electric field, that is nothing but electrostatics. When electric field is given, means some voltage is applied which is in stationary position. So how the coil is rotating, everything is, that is nothing but a static electric field, that is electrostatics. Next, static magnetic field. So this is nothing but magnetostatics. Next, interaction of both electric field as well as magnetic field, that is nothing but a electromagnetic field. Next, the particular quantity that wave is propagating in a electromagnetic field, that deals with the plane wave propagation. So this plane wave propagation is for EC students, they are dealing with microwaves and all. Okay, so these are the main topics in main modules in electromagnetic fields, that is electrostatics, magnetostatics, electromagnetic fields, next plane wave propagation. So next coming to so why we are going for this electromagnetic field theory, as already we have a circuit theory. So what is the reason why we are going for electromagnetic field theory? So for that, so we'll take differences between the circuit theory and field theory. So here circuit theory is dealing with voltage and current, whereas field theory is dealing with electric field and magnetic field. So here these voltage and current are scalars, whereas in field theory these electric field and magnetic field are vectors. So wherever this circuit theory is not applicable, we are going for field theory. That is the main reason why we are going for field theory. Next here, radiation effects are neglected in circuit theory, whereas in field theory, radiation effects are considered. Why? Because we are dealing with electric field and magnetic field and electromagnetic field. So that is the reason we are going for field theory. So here, radiation effects are considered here. Next, coming to the circuit theory, here the transmitter and receiver circuits can be analyzed, but medium like free space cannot be analyzed. Means here we are not analyzing in free space, whereas in field theory all mediums can be analyzed. Next, circuit theory is useful at very low frequency, but here field theory, it is independent of frequency. Means here the skin effect is not considered in circuit theory, whereas it is independent of frequency in case of field theory. So next, coming to the applications of electromagnetic theory. So here, electromagnetic theory is applicable to microwaves, antennas, electrical machines and transformers, relays, in case of power systems, electromechanical energy conversion systems, and wireless communication like satellites, TV and cellular systems, and also optical fiber communications. So these are the applications of electromagnetic field theory. So here, next coming to the basics of vector analysis. So to discuss all these topics, means whatever the electromagnetic field theory comes, that is electrostatics, magnetostatics, electromagnetics and plane wave propagation, we are basic idea is basic thing is required, subject is vector analysis. The students can able to know the vector analysis. So coming to the vector analysis, so what is vector and what is scalar? So vector is a quantity which has both magnitude and direction, whereas scalar is nothing but only it has a magnitude, there is no angle. Okay, so that is the difference between the vector and scalar. So coming to the vector analysis, here in communication systems, the circuit theory is valid at both transmitting and as well as the receiving end, but it fails to explain the flow between the transmitter and receiver. So that is the thing. That is the reason we are going for electromagnetic theory. So circuit theory deals with only two variables, that is voltage and current, whereas electromagnetic theory deals with many variables like electric field intensity, magnetic field intensity, and everything. So etc. Okay, these are the main things in electromagnetic field theory. See, and also mostly three variables that is involved in a electromagnetic field problems. Okay, so hence this solution becomes a complex solution. So for solving these field problems, we are strong background of the vector analysis is required. So that is the reason these vector analysis basics are very much important in this electromagnetic field theory. So next, coming to the vector analysis, I am explaining about the basic things in vector analysis, that is what is scalar product, vector product. Okay, so in that, first dot product. As we know, in already we dealt with in physics in second year vector analysis, that is what is a dot product. So it is called scalar product, means let theta be the angle between the two vectors. So A dot B is nothing but modulus of A modulus of B cos theta. So this is the dot product. The result of dot product is a scalar. Okay. So here, for example, so here work done or energy, which are the scalars. Next, cross product. So it is also a vector product. So to find the direction of this, yes, here consider a right threaded screw being rotated from A to B. So I am rotating this from A to B. So that is in particular perpendicular to the plane containing the vector A and B. So the cross product of this is nothing but A cross B equal to modulus of A modulus of B sin theta in the direction of n. So here S equal to modulus of S A n. S is nothing but modulus of A modulus of B sin theta. So here, as we know that A cross B equal to minus B cross A. So these are all the properties of this cross product. So next, coming to the del operator. So del operator means it is a vector in three-dimensional partial differential operator. So del is a vector three-dimensional partial differential operator. So it is defined in Cartesian system as del equal to dou by dou x of I, dou by dou y of j, and plus dou by dou z of k. So this is a del operator. This is the equation for this. So del is a very important factor operator. So here we have three possible operations with del. So they are gradient, divergence, and curl. So we'll see what is gradient. So gradient is a basic operation of a del operator that can operate only as a scalar function. So gradient is nothing but it is a scalar function. Consider the scalar function t here. So the gradient of t can be mathematically defined as gradient of t equal to dou by dou x of I plus dou by dou y of j plus dou by dou z of k. Okay, so here del of t is a vector. So then we can write it as dou t by dou x I plus dou t by dou y j plus dou t by dou z k. So here gradient of scalar function is a vector function. So gradient is a basic operation of a del operator that can operate only on a scalar function. Okay, so getting it? Okay. Then next, coming to the divergence. So what is a divergence? So divergence is a basic operation of a del operator, again, which can operate only on a vector function. So previously gradient is operated on a scalar function. So here divergence is operated on a vector function through a dot product. So previously it is a cross product. Okay. So here So considering a vector function here A, so here it is divergence of a vector is mathematically defined as del dot A equal to dou by dou x of Ax plus dou by dou y of Ay plus dou by dou z of dou z. So here divergence of a vector function is a scalar function. Okay, so here, so let us take for example, so flux density vector is there, so that is D is a flux density, then D dot ds. Okay, S is nothing but is area. We are considering a field some particular area, so D dot ds equal to flux through a surface, that is surface area ds. Okay, distance. So the flux through the entire surface is D dot ds. So that is nothing but divergence of D gives net outflow of flux per unit volume. So we are considering it in a unit volume. So del dot D equal to limit del V tends to 0, double integral of D dot ds by del V. So this is the mathematical expression and dot product. So that is a divergence. Next, curl. So curl is a basic operation of del operator which can perform only on a vector function through cross product. Previously, divergence is applied in dot product. Now it is curl is operated in cross product. So del cross A is nothing but a curl of A. So curl of A is defined as like this: dou by dou x of I plus dou by dou y of j plus dou by dou z of k into, this is the vector. Okay, so here these are the properties here. Curl of a vector function is a vector function, and curl deals with a rotation, means whenever the, so we are considering some x, y, z, let us take like this. Okay, the point here, we have a point charge here. So when it is moving, means when it is rotating like this, so we are considering a curl deals with this rotation of this point. Okay, if the curl of a vector field vanishes, so it is nothing but a irrotational field. Next, curl is mathematically defined as a circulation per unit area. So that curl V equal to circulation by unit area. So that is nothing but limit delta S tends to 0, closed integral of V dot dl by delta S. So all these are vector analysis basics. Okay, so next, in the next class we will discuss about the, so what are the coordinate system, so how we are transferring from one coordinate system to the another coordinate system. Okay, so these are the references. So mainly the engineering electromagnetics by William W.H. Haidt. Here MNO Sadiku, that is Elements of Electromagnetics, Oxford University publication. And for problems and solutions we have Pramanik, that is Prentice Hall, India. And one more book is there, that is CBS publications by Electromagnetic Field Theory, Problems and Solutions of Electromagnetic Field Theory, that is CBS publication. Thank you.